Welcome back to the deep dive. We're here again to, dive into some complex stuff and make it make sense for you.
That's the plan.
Today, we're tackling something that works silently all around us.
Hmm.
The Saudi Fire Protection Code 801.
Mm.
It might sound dry, regulations often do, but think of it as a language of safety. And today, we're learning the basic vocabulary and the definitions. It's your shortcut, really, to understanding fire safety foundations in Saudi Arabia.
And knowing these definitions, it's just essential. It's not just jargon for engineers. They
Yeah.
shape how buildings get built, how dangerous goods are stored. I mean, it directly affects the safety measures we all encounter, often without realizing it.
That's a really good point. You don't think about the definition of exit until you actually need an exit,
Yeah,
you know.
exactly.
So our mission today, let's unpack some key terms from the code. We'll look at some nuances, maybe a few surprises, and connect all this technical talk back to everyday life so you can feel informed, not buried in regulations. Okay, let's get into it.
Sounds good.
So thinking big picture,
Hmm.
the absolute core of any fire code has to be protecting people, right? Getting them out safely. How does Code 801 frame that?
Well, it starts right at the beginning in Chapter 1, Scope and Administration. That section lays the groundwork, and the central idea is something called means of egress.
Means of egress, okay.
The code defines it very precisely. A continuous and unobstructed path of travel from any point in a building or facility to a public way. Continuous and unobstructed. Key
It's
words.
continuous and unobstructed. Okay, that makes sense. Like no locked doors in the way,
Yeah.
no storage blocking the path.
Precisely. And it's not just one thing. The code breaks means of egress down into three distinct parts. You need all three.
Okay, what are they?
First up is exit access. That's the path from wherever you happen to be, say in your office or apartment, to an actual exit.
So like the corridor outside my door leading towards the stairway.
Exactly. That corridor is the exit access. Then you get to the exit itself.
Right.
This is the protected part of your journey out. It's specifically designed to resist fire for a certain amount of time. Think of a fire-rated stairwell or maybe an enclosed exit passageway. It's built to keep you safe during transit.
Got it. Protected passage. And the third part.
That's the exit discharge. This is the final bit that takes you from the exit, like the bottom of that stairwell, all the way out to what the code calls a public way.
A public way. So like the street.
Yeah.
Or an open area away from the building.
Exactly. An egress court leading to the street, maybe a path. So essentially a safe place clear of the building. So you have exit access, exit, and exit discharge, all three linked together.
That's actually quite logical when you break it down.
It is, but what I find really insightful is how the code thinks about everyone's ability to use that path. It introduces the concept of an area of refuge.
Area of refuge. Tell me more.
It's defined as a temporary safe area for persons unable to use stairs to await instructions or assistance during evacuation.
Ah, so for people who might have mobility issues, for example.
Precisely. In multi-story buildings, you need these designated spots. They're built to be fire-resistant, usually have their own air supply, and crucially, have communication systems so people can signal for help and wait safely for rescue personnel.
That shows incredible foresight, planning for scenarios where not everyone can just rush down the stairs.
It really does. It's about ensuring safety measures consider the diverse needs of occupants.
Does the code detail the kind of assistance, or is it more about providing that safe space?
It mainly focuses on mandating the space itself, the construction, the fire rating, the accessibility, the two-way communication. The operational side, the specific rescue procedures, often integrate with the building's overall emergency plan and local emergency services protocols. But the code ensures the place exists and is functional.
It really changes how you look at a building, doesn't it? Knowing these invisible safety nets are woven into the design, corridors, stairs, even designated waiting spots.
Absolutely. Silent guardians, as you said.
Okay, so we know how to get out. But what about the things inside the building that make getting out necessary in the first place?
Yeah.
The hazards.
Right. This leads to a really important area, how the code defines dangerous materials. And it makes some critical distinctions, particularly with liquids.
Yes, a lot of people use flammable and combustible almost interchangeably. How does the code separate them?
It all comes down to the flash point, specifically the closed cup flash point. That's the lowest temperature at which a liquid gives off enough vapor to form an ignitable mixture with the air near its surface. Not burn continuously, just flash.
Okay, the flash point. So what's the magic number?
For a flammable liquid, the flash point is below 38 degrees Celsius, so relatively low temperatures. And even then, it breaks it down further into Class IA, IB, and IC based on flash point and boiling point.
Class AA is the most volatile, think diethyl ether, maybe?
So easier to ignite at lower temps. And combustible liquids? Combustible liquids have a flash point at or above 38 degrees Celsius. They still pose a fire risk, of course, but they need a bit more heat to give off those ignitable vapors. These are also classified Class 2, I3A, IB, based on ranges above 38 degrees C. Think diesel fuel or heating oil, often in these categories.
So that temperature threshold, 38 degrees C, is the key dividing line.
It's the fundamental difference. And it's not just academic. This distinction dictates major differences in how these liquids must be stored, handled, and what kind of fire protection systems are needed around them. It's why gas stations have specific pump designs and underground tanks versus how, say, motor oil might be stored. The definitions drive the safety requirements.
It's amazing how one number can ripple through so many regulations.
Yeah.
What about things that go boom, explosive?
Yes. Explosives. The code gets very specific here, too, referencing the DOT and classifications. That's the Department of Transportation System. Divisions 1.1 through 1.6.
And those divisions aren't just big bang versus small bang, are they?
Not at all. They describe the nature of the hazard. Division 1.1, for instance, is a mass explosion hazard, think dynamite, where pretty much the whole lot could go off at once.
Okay, scary.
Then you have, say, Division 1.4, which represents a minor explosion hazard. The effects are largely confined to the package itself. It won't cause widespread devastation. Think of some types of consumer fireworks, perhaps. Knowing this difference is critical for everything from shipping regulations to how far apart storage magazines need to be.
Makes sense. What other sort of unusual hazards does the code define?
Well, there are pyrophoric materials. These are chemicals defined as self-igniting in air at or below 54 degrees Celsius.
Self-igniting, just poof.
Pretty much. Exposed to air, they react and catch fire without any external ignition source. Very dangerous, requiring highly specialized storage, often under inert atmospheres.
Wow, okay. What else?
Then you have water-reactive materials. The code categorizes these based on how severely they react with water. Class 3 is the most severe. They can react explosively or produce flammable gases upon contact with water.
So for firefighters, that's crucial. You can't use water on a Class 3 water-reactive fire.
Absolutely not. It would make things catastrophically worse. It dictates the need for alternative extinguishing agents, like dry chemical powders. Class 1 might just release some energy or a non-hazardous gas, a much lower risk.
And you mentioned hot work earlier. That seems almost ordinary compared to pyrophoric materials.
It might seem ordinary, but think about how many fires start from welding sparks or cutting torches. The code defines hot work specifically welding, cutting, soldering, torch-applied roofing, because these activities are known consistent ignition sources. By defining it, the code mandates permits, fire watches, specific precautions before the work starts. It's proactive safety for a common industrial risk.
So these definitions aren't just labels. They actively trigger specific safety protocols. They shape the environment around us, the design of the gas station, the rules at a construction site, the procedures in a lab.
Precisely. They translate risk assessment into actionable requirements built into our surroundings.
Okay, so we know the dangers, we know the way out. What about the things inside the building designed to actively fight a fire or warn us? The systems.
Right, the active protection systems. The code has clear definitions here, too. An automatic fire extinguishing system is the broad term for any approved system that detects a fire and activates suppression automatically, without needing a person to flip a switch.
Like sprinklers.
Sprinklers are a prime example. The automatic sprinkler system is specifically defined as that integrated network of pipes and sprinkler heads, connected to water, designed to engineering standards. Then there's the automatic smoke detection system, smoke detectors, designed to sense smoke particles and sound an alarm automatically. Early warning is critical.
And that automatic part is key, isn't it? It means they react based on conditions, not waiting for someone to notice the smoke or flames.
Exactly. That immediate automatic response can be the difference between a small, contained fire and a major disaster. It buys invaluable time.
So those are the active systems. What about features built into the building itself? Passive protection.
Good point. The code relies heavily on passive fire protection, too. Things like fire barriers and fire partitions. These are essentially walls, floors, or ceiling assemblies designed and tested to resist fire for a specific duration, like 1 hour or 2 hours. Their job is containment, stopping the fire from spreading horizontally or vertically.
Like compartmentalizing the building.
Exactly. Then you have smoke barriers, which are similar but specifically designed to stop the movement of smoke. Smoke often travels faster and further than flames, and it's incredibly dangerous, so controlling its spread is vital.
And you mentioned something called fire blocking. What's that?
Fire blocking. This is interesting. It's about using approved materials like lumber, gypsum board, insulation to fill the concealed spaces within walls, floors, and ceilings,
Why fill those spaces?
to prevent fire and hot gases from racing through those hidden voids. Think of the spaces between wall studs or above a dropped ceiling. Fire blocking seals them off at intervals, slowing down the fire's unseen spread. It's like putting dams inside your walls.
Clever. All these hidden features working together.
And one more related definition that's crucial for firefighting operations: the fire apparatus access road.
So basically a road strong enough and wide enough for a fire truck.
Essentially, yes. The code defines the requirements for these roads with turning radius, surface strength, overhead clearance to ensure fire departments can actually get their vehicles close enough to the building to connect hoses, raise ladders, and effectively fight the fire. If they can't get close, their job becomes much harder or even impossible.
So even the driveway or access road is part of the fire safety plan.
Absolutely. It's all interconnected. These passive elements, active systems, access routes, they're the invisible shields, the silent sentinels in our buildings.
It really does give you a new appreciation for modern construction codes.
It does. And the level of detail sometimes, it can be surprising.
Let's talk about some of those perhaps unexpected definitions. Things you wouldn't immediately think belong in a fire code, but show how thorough it is. Like sky lanterns.
Yes, that's a great example. The code actually defines a sky lantern, a device with an open flame used for visual effect for entertainment purposes that becomes airborne.
Huh. Why define that specifically?
Because they're a known fire hazard. Think about it, an uncontained flame floating away on the wind. They've started wildfires, structure fires, so the code defines them to regulate or even prohibit their use. Acknowledging this seemingly harmless entertainment can be quite dangerous.
That makes perfect sense when you put it that way. What about how the code classifies buildings themselves?
Occupancy groups. This is fundamental. The code classifies buildings based on their use because usage dictates risk and occupant characteristics. A really interesting example is institutional group I.
Okay, what falls under Group I?
This group covers places where people receive care or supervision, especially if they aren't capable of saving themselves or if they're detained. But it's not monolithic. The code drills down into conditions within Group I. Yes. For instance, Condition 1 is for facilities where the occupants are generally capable of self-preservation, but might need some assistance. Think of an assisted living facility.
Okay.
Condition 2 is for places providing medical or nursing care where occupants are not capable of self-preservation. This is your typical hospital or nursing home. The requirements here are much stricter.
Right, because the occupants can't easily evacuate themselves.
Exactly. And then there's Condition 3, which covers facilities where occupants are under restraint or security measures like prisons or detention centers. Again, different risks, different egress challenges.
So the occupancy group, and even the condition within that group, radically changes the safety requirements. Fire alarms, sprinklers, egress routes.
Absolutely. It's incredibly nuanced. The code isn't just saying it's a hospital. It's considering the specific capabilities and vulnerabilities of the people inside that hospital when setting the safety rules. It tailors the protection to the occupants.
That's really thoughtful design. What about smaller things we might not even consider a fire risk?
Well, think about decorative materials. The code defines this as basically anything applied to interior surfaces, walls, ceilings. Why? Because some materials burn much faster than others, contributing to rapid fire spread. So the code regulates the types of decorative materials allowed, especially in exitways.
So even the wallpaper or curtains are considered.
Potentially, yes. And another one, aerosol products. Chapter 51 deals with these specifically.
Like hairspray or spray paint.
Exactly. They're classified based on their chemical heat of combustion, basically, how much energy they release when they burn. This classification then dictates how they can be stored and displayed in shops, defining things like the retail display area, allowable quantities. Because under fire conditions, those cans can rupture or explode.
It's fascinating. From the main structure down to the cans on a store shelf, the code is trying to anticipate and mitigate the risk.
That's the goal. Every element plays a part in the overall safety picture.
Well, As we start to wrap up this deep dive into the definitions of the Saudi Fire Protection Code 801, I hope it's clear that these aren't just, dry bureaucratic documents.
Not at all.
They're packed with practical knowledge based on hard-won experience, all aimed at saving lives and property.
Absolutely. We've really just skimmed the surface of the definitions chapter today, but you can already see the precision, the real thought that goes into crafting these regulations. They aim to cover almost every conceivable scenario to protect people.
So maybe the next time you walk into an office building, a mall, or even look around your own home, take a second. Consider that invisible network, the definitions we talked about, the regulations they trigger, the systems they mandate, all working constantly, silently behind the scenes to keep you safe.
It's quite a system.
It really is. And it makes you wonder what other aspects of our modern world, our built environment, are governed by this kind of meticulous, often unseen detail. What other silent guardians are out there? Something to think about.